Good afternoon. We started yesterday with a chapter called as managing money, and in that we discussed about something that was called as simple interest. I'll quickly revise what is simple interest. We'll solve a couple of problems based on that. Then we'll start with the next one. Supposedly someone has lent you some money and that money is, let's say, 50,000 rupees. So that is the principal amount. The rate of interest has already been decided. That rate of interest is 10%. The rate of interest is written as percentage, but it's not only percentage, it's percent per annum. So 10% per annum is the rate of interest. And the time for which the loan has been taken is, let's say, 5 years. So what is simple interest? By simple interest we say that because someone has given us the money and we know that because of the growing economy everything else will be getting more and more expensive every year. So if I give the same amount of money back after 5 years, it is almost cheating someone of his money. Because the money would have grown, the value of the money would have grown, but it has been not growing. This 50,000 rupees is with me, and my friend would have bought something, and that something would have been growing in its value with the growing economy. But today, what has happened is these 50,000 rupees are with me. I am enjoying whatever benefits of these rupees. But when I return back after 5 years, my friend would not get those kind of returns because he will only get 50,000 rupees, and that is very unfair. So if the world agreed that there will be some kind of compensation that we call as interest. So we will call it interest. And because this is simple interest, we write simple interest is equal to PRT या PTR upon 100. This is equal to principal 50,000 into rate of interest is 10 into time is 5 years upon 100. This double zero goes 5,000 into this 25,000. So the principal amount was 50,000 rupees and the interest is 25,000 rupees. The total amount that we have to return is A is equal to P plus I, which is equal to 50,000 plus 25,000, which is equal to 75,000 rupees, and this is the amount that we have to return. This is all based on the simple interest logic. This formula is of simple interest. Now anybody can ask, sir, if there is some calculation about calculating the interest and then finding out the amount, can we do it the opposite way? Yes, we can. There are some problems which are completely opposite. So the problem is like you borrowed 50,000 rupees from a friend or someone, and in the end you had to pay 70,000 rupees back. If the tenure of the loan was 4 years, this is time, tenure, then calculate the rate of interest. So we'll first start with saying A is equal to P plus I, which is equal to P is 50,000 rupees plus I is equal to 70,000 rupees. Subtracting, we get I is equal to 20,000 rupees. But I, simple interest, is also equal to PTR upon 100 or PRT upon 100. The principal is 50,000. Tenure is 4 years. Rate I don't know. $500 into 4 is 5,000. Sorry, 500 into 4 is 2,000. Why? Is 2,000 into R is equal to 20,000. Let's divide. So we get R is equal to 20,000 upon 2,000 is equal to 10%. So the loan was taken at 10% rate of interest per annum, every year, that is. So this is what simple interest and the calculation based on simple interest look like. Now, if there is something that we call as simple interest, there must be something that we call as compound interest. The next kind of interest is called as compound interest. What does it mean? Please pay attention to this. The interest is initially that the interest that we saw was called as simple interest. It is obvious that if something is simple, something will be not simple. Otherwise, we would have just called it interest. Because we gave a special name simple interest, there must be some more kind as well. And that is what is compound interest. But what is compound interest? Why does the idea of compound interest ever come into existence? We'll see it here. Please pay attention to this. So supposedly my friend lent me 50,000 rupees, that is principal amount. The rate of interest is, no, let's take not 50,000, the principal amount is, let's make calculations very easy. So this is 1 lakh rupees. The rate of interest is 10% and the tenure is variable in the sense that he said that you need this money, I have this money, I don't need it right now. I'm doing fine. This is something I would have invested in buying something. It is okay. You take it, you use it as long as you want. When you're done, return that with 10% of rate of interest. And I was perfectly fine with that. Okay, you will take the money. So I took this 1 lakh rupees. I agreed that the rate of interest will be 10% per annum. And then whatever be the tenure, will make the calculations. So in my calculation, I said I said that if the tenure is, see this, t is equal to 1 or 2 or 3 and so on. I is equal to PRT upon 100, which is equal to principal is 1 lakh into rate of interest is 10% into T upon 100. 1000 into 10 is 10,000 into T. So if the value of T is 1, then the interest will be equal to 10,000 rupees. 10,000 into 1. If the time is 2 years, so the interest will be 10,000 into 2 years, that is 20,000. Then it will be 30,000. But there is an interesting problem here, and this is what my friend pointed out. My friend told me that don't take it like I want more money out of this. I'm not making money out of this. But the reason why you are giving me interest is the economy will grow. And if the economy is growing, then the value of money will be reducing. So you want to compensate by paying some extra amount. And every year you will pay that extra amount, 10,000 rupees. So the second year you will pay 10,000 more, so together you pay 20,000 interest. Third year you will pay 10,000 more, so together you are paying 30,000 rupees of interest. Basically you are paying 10,000 rupees of interest every year. I completely agree with this, this is perfectly fine. He is saying, but the money that I gave you initially, at the start of the year, please pay attention to this now. P, when the time is equal to 0 years, then principal amount is 1 lakh rupees. But then after 1 year, T is equal to 1 year. After 1 year, my friend has given me 1 lakh rupees plus this interest is also with me. I should have been paying this interest, but I have not paid this interest. So now I owe him 1,10,000 rupees. Why? Because this 1 lakh rupees was already given to me by him. He had lent me 1 lakh rupees. But the 10,000 rupees I should have paid as interest for the first year, which I have not paid back. So even this money is belonging to him, but it is with me. So the total money after 1 year that is with me is 1,10,000. And in the next year, the interest will be charged on this amount, not 1 lakh rupees. So what will happen the next time is, the interest will be charged on this amount. So I will be equal to I is equal to PRT upon 100. This is equal to P is 1,10,000. R is 10. Next year we'll only calculate for 1 year. Divided by 100. So you get rid of this 100 and these two zeros. 1100 into 10 is 11,000 rupees will be the interest for the second year. Here for the 2 years together, the total interest was 20,000 rupees. That was for simple interest. But in case of compound interest, the total interest is, initially the interest was 10,000 rupees and then the new interest is 11,000 rupees. So after 2 years, the amount of interest that you have to pay is not 20,000 but 21,000. So total interest after 2 years is equal to 10,000 rupees in the first year plus 11,000 rupees in the second year, and that is 21,000 rupees after the second year and at the end of the second year. So if I decided to return his money at the end of 2 years, I should return the first obvious principal is 1 lakh rupees and I should return 21,000 as well. This is as per the formulation or the calculation based on compound interest. In compound interest, what happens is, the money that you have taken is your principal amount for the first year. But you are not paying any interest already. You will pay entire thing in the end. So if you are not paying the interest, then the interest is getting added to the principal amount, and for the next year, this together, the sum, the amount will become the principal. So 10,000 rupees was the principal initially. 10,000 rupees, sorry, 1 lakh rupees was the amount A, was the principal amount initially. 10,000 was the interest. They together get added, and 1,10,000 is the total amount that I have to pay at the end of 1 year. But because I don't pay it, this amount becomes the principal amount. So after 1 year, it is like we two sit together, me and my friend sit together, saying, I don't have any money to pay back. He says, it is fine. Let's just calculate. He says, you took 1 lakh rupees. I said, yes. 10,000 rupees comes out to be the interest. I said, yes. So together, at the end of 1 year, they become 1,10,000 rupees. I said, perfectly fine. But I said, this is amount, this is not principal. He said, no, you are missing the point. Now, at the end of 1 year, the amount is 1,10,000. Yes. This is the money that you have given by me. I have given, you have the money. How much money do you owe me now? 1,10,000 rupees. So for the next year's calculation, this will become your principal. So the interest is added to the principal, and the interest also becomes a part of the principal for the next year. As a result of that, the next year's interest is not 10,000. The first year's interest was 10,000. Second year's interest is not 10,000 here. It is 11,000. And because of that, the total interest of 2 years is here would have been 20,000. Here it is 21,000. So what has happened is in compound interest, as the years grow by, the interest paid every year increases. The interest to be paid in every year will increase. In the first year you are paying 10,000 rupees. In the second year you are paying 10,000 again in simple interest. That's why together they are 20,000. In the third year 10,000 again. Here it is not like that. In the first year the interest is 10,000, same as the first year in simple interest. But second year onwards everything will change. Now second year onwards the interest will be 11,000. Then there will be something more in the third year, something even more in the fourth year, and the interest will keep on increasing. This is called as compound interest. Are we going to say, if we say if the loan is taken for 10 years, then are we going to calculate it 10 times? First year, second year, third year? No. We'll have a formula which will get the compound interest directly. And that formula is like this. Please kindly pay attention to the formula. A is equal to the amount that you have to pay right at the end of the loan tenure. Whatever be the tenure. Tenure can be 1 year, 2 year, 3 year, 4 year, 5 year, whatever. A amount is equal to principal P into bracket 1 plus R by 100 bracket raised to T. This is the formula. How has the formula come? We'll talk about this later on when we actually meet. Right now, let's assume that this is the formula, and with this formula, we calculate the interest. If I take the value of T is equal to 1, so the formula becomes A is equal to P in bracket 1 plus R by 100, which is equal to, in this case, the principal amount was 1 lakh. 1 plus R by 100, 10 by 100. 1 plus 10 by 100 is 1 by 10 is 0.1. 1 plus 0.1 is 1.1. So 1 lakh into 1.1. So it is 1,10,000 rupees. This will be the amount that you have to pay after 1 year, which is perfectly same as this. 10,000 rupees of tax, 10,000 rupees of interest plus 1 lakh rupees of principal. Together will be 1,10,000. So in the first year, the simple interest and compound interest are perfectly same. They go absolutely same way. This is like a train starting from the two different trains are starting from this station. Till the first station, both are going parallel. Then this one goes like this, and then this one changes its path, the second train. So till the first year, both simple interest and compound interest are going absolutely same. It is after the second year that the compound interest shows its true nature, and you get to understand it. So if I take the value of T is equal to here, what will be the compound interest? Let's see this. ₹1 lakh into 1 plus 10 by 100 bracket raised to 2. T is equal to 2. So A is equal to 1 lakh into 1 plus, this is 0 chala gaya, 1 by 10. 1 by 10 plus 1, 11 by 10 square. This is equal to 1 lakh into bracket 121 upon 100. We are making square. 11 square is 121, 10 square is 100, and these two zeros will cut. So this is 1000 into 121. So 121,000. So that is 1,21,000. 1 lakh was the principal amount, 21,000 is the interest. So the compound interest after 2 years is 21,000. Here it is 20,000. And that's how the tracks have changed now. So this is the entire logic about the compound interest. This formula is very unique. We can use it for many purposes. Supposedly we are talking about the population of a country. The population initially was 20,000 people stayed in a village. It's a big village, let's say. So the population of that big village was 20,000 people. And it was found that the rate at which the population increases is 4%. I don't know if this is realistic or not, I'm just giving a number like that. 4% every year. So after 2 years, what will be the population? So we'll use the formula A is equal to P into bracket 1 plus R by 100 bracket so T. T is 2 years. P is 20,000 into 1 plus 4 by 100 bracket square. So this is equal to 20,000 into 26 by 25 square, or rather let's keep it like that. This is equal to 20,000 into 104 upon 100 square. 104 square will be 100 plus 4 bracket square is 10,000 plus 16 plus 2 into 4 into 100. 816. So this is equal to 20,000. Solving it here, 20,000 into 10,816 upon 10,000. 4 zeros, 4 zeros are getting cancelled. 2 into this is 2 into this value is 1632. 8 2 is 16 carrying 1 21,632. So the population of that city or population of that village after 2 years will be 21,632. I don't think it is really that much. I don't think it increases so rapidly. But yeah, I mean, if we assume 4% of growth, which is not like that. Every year 4% growth is not possible for population. But like I told you, this is not a realistic number. I'm just giving a number. So the population growth of a village, of a city, of a country can be calculated, estimated using this formula. Like if you have sore throat, where I have a little bit of bad throat today. It's been some time now. So if you also have that, then some people have throat infection, and there are obviously bacterial infection. So the number of bacteria present inside a particular human being's body can also be, they will multiply after few hours. Their bacteria have a different reproductive cycle. Human beings, when they marry and they reproduce, the child is born after 9 months. In this case, it is not like that. The bacteria will have much lesser cycle. Bacteria do not live for 9 months anyway. So for them to produce after 9 months is impossible. They will take few hours to reproduce, and then their bacteria number will increase. And as the numbers increase, within 6 hours, within 8 hours, people who are only feeling sore throat, they start to feel feverish, then they develop fever, and then they are bedridden with flu for about 2 to 3 days. This entire thing happens very quickly because the time of multiplication or time for reproduction for that particular bacteria is very small. But the number of bacteria present can also be calculated by the same formula. I had bought a bike at 1 lakh rupees. It is estimated that every year, because of the using the bike, the machine parts will rub against each other because of the friction. There will be a little bit of wear and tear. And that is estimated with every machine. Like if you take, for example, a submarine is commissioned, or a ship is commissioned, naval ship. Then the navy ship would be, the ship will be built with 1 lakh crore rupees, let's say. Just again giving just a number, 1 lakh crore. Then it is already estimated that the rate of decay, what is decay? Because of the friction, because of wear and tear, the cost will reduce. The effective value of that particular thing will reduce. So it will no longer be of the same value after 1 year, after 2 years, after 3 years. The value will keep on reducing. It is already estimated that the rate of decay is 4%. And then this is scientifically determined. It is not determined just like that. It is scientifically determined what will be the rate of decay for this kind of machine. There are experiments conducted on certain machines, and then it is determined how much time is taken and what is the decay after 1 year, after 6 months, after 10 months, and so on, and the number is calculated. So once you know that the decay is at 4%, then the table is finally used. A is equal to P into bracket 1 plus R upon 100 bracket raised to T. But in this case, it is not taken as R1 plus, it is taken 1 minus R upon 100. Why? Because the original value is reducing this time, it is not increasing. In case of the interest, actual interest, the value would be increasing, the interest would be increasing as the years go by. If you're talking about the population of a town, more and more people will get married, they will have their married life, they will reproduce, the new child will be born, the population of the town will keep on increasing. In this case, what is happening is, because of the machine parts brushing against each other because of this friction, there will be some kind of wear and tear, and the value will be reducing continuously. So for the reduction, the formula remains same, but just that instead of plus, it is minus here. And then you calculate what should be the value of T when A effectively becomes 0, or A effectively becomes only 10% of this value. So it is estimated that after so many years, the given machine, the naval ship or a submarine, will be reduced to only 10% efficiency, 10% efficacy. And that is when the submarine or the naval ship will be decommissioned. And maybe it will be turned into a museum or whatever, but it will no longer be in service. It is already decided, and the number of years of service are already estimated. Like in case of INS Vikrant, Indian Navy ship Vikrant was to retire much earlier, this calculation. But then on the year of retirement, the Navy conducted a thorough checkup again, and it was determined that despite of expected wear and tear being a particular level, actually it does not happen, and Vikrant is still in a condition where it can be used as a warship. So a few years of extension was provided. Despite of the extension, and despite of not getting an extension, or despite the army ship being in service, every year there will be this survey that will be conducted. What is the condition of the essential parts, machine parts, engine, and everything else as well. Every survey will be conducted. And in that survey, people will realize we expected 4% of rate of wear and tear, but actually it is more, because the salt water, the water in the ocean is such that there is a lot of deterioration, and as a result of that, it is not 4%, it is 4.5% or 5%. And appropriately new calculations would be done. Sometimes it is not like that. Sometimes we estimated 4%, but the ship is, or the deterioration is happening, decay is happening only at 2% or 8% or 2.8% or 3%. Then everything will change. But for the sake of disintegration or decay, we use this formula. What kind of, not reactive disintegration, we use this formula for the decay that is based on the loss of value. and that is for all the machine parts, even for our bike. Let's say we're not talking about the this machine, what do you say, submarine or anything like that. So we have 1 lakh rupees worth of bike, and it is used, it is estimated that the decay will take place at 4% per annum, at the rate of 4% per annum. So what will be its value after 2 years? I could take 5 years or anything like that, but because I'm not carrying any calculator, I will just put 2 years here. So we will just calculate A is equal to 1 lakh is the principal into 1 minus 4 by 100 square. 1 lakh 96 by 100 square. This is equal to 1 lakh into 100 का square is 10,000 and 96 square. 96 square is 100 minus 10 bracket square. 100 minus 4, sorry, bracket square. A minus b bracket square, a square minus 2ab plus b square. Four zeros are getting cancelled. 10 will be multiplied, so it is 92,160 rupees. So the bike that was having a value of 10 or having a value of 1 lakh rupees at the time of buying, because of the friction, because of the wear and tear, because of the decay, the value of the bike after 2 years is reduced to 92,160. All of this is based on the same compound interest formula. It's just that we put minus sign here in case of disintegration or decay. I hope you get this. I hope you understand this. Please solve the problems. Most of this chapter is done. It's just that exponential growth and exponential decay is the only part that I have skipped, that we'll discuss when we meet together. Everything else from this chapter is done. Taxation, I am not teaching this online.